Okay, so this is the video on strings. If you have any prior programming experience in a language like Java or Python, you might be used to working in string or with strings in a very different way from how you have to work with strings in C. So even if you're comfortable with strings in those languages and you might notice some similarities between other things in those languages, I think it's still probably a good idea to go ahead and brush up on some things that are specific to the C language when you're dealing with strings. Because if you don't, you might get a little lost or confused, or you might wind up missing some things that it might not be clear or intuitive right away. So let's get into it, starting with what are strings. And in the C language, strings are just character arrays, arrays of characters. So what that means, or the implication of that at least, is that if you're not super familiar with arrays, you're a little bit iffy on how they work, what they are, just in general, you'll probably have a harder time wrapping your head around strings. So if that's the case, I would recommend maybe taking a look at maybe the arrays video or some material online on arrays in general before jumping into strings. If you are pretty good on arrays, then strings should be pretty easy. It's not too much of a leap. So yeah, definitely make sure you have a solid foundation with arrays before you jump into working with strings. And the other thing that we're going to talk about is some useful string library functions included in string.h, which is a header file that I'll go ahead and include right now. Anytime you're planning on working with strings, it's probably a good idea to include this because you don't want to have to reinvent the wheel and write some of these functions over yourself. So definitely some useful stuff in string.h. So yeah, let's go ahead and let's make a string. Char my string, and like I said, it's a character array. So let's go ahead and, I don't know, let's make it say hello. And this shouldn't look too dissimilar to what we were doing in the arrays video at first. Right? I mean, you have, why is there a parenthesis there? Yeah, so you have an array of characters, right? You know that chars take single quotes, so that's why those are there. This isn't too different from just doing something like this. You know, the only difference is that now you're working with characters instead of numbers, right? So it's the same sort of idea. Remember the whole box diagram and all that stuff from the array video. That all is, you can apply that here. So just think you're working with an array of characters. So let's go ahead and print the string. %s is the format specifier for strings. You can remember because string starts with s. And it's called myString. Let's print this. And there's a couple things wrong with this program. And you'll notice when we try to print it, we get this hello, and we get a couple garbage values at the end. Why does that happen? Why does that happen? So in the C language, strings are arrays of characters, but we need to append something to this. Terminated by a 0 or these are equivalent, you can use either. So 0 or the \0 character, which is called the null terminator. It lets the compiler know that it's hit the end of your string, because otherwise it'll keep trying to read and it'll hit garbage values in memory, which is where this comes from. These are just garbage values in memory that it's trying to render to the screen, but it doesn't actually mean anything. So even though you're not going to see it, you do need to let the compiler know when to stop reading your string. And the way to do that, if you're hard coding a string this way, is to include this 0 or \0 at the end of your string. Either one works. These are both equivalent, either a 0 like that or a \0 character. But it is important that you include that. So when we go ahead and run this now, it does just say hello. So that's one way that you can sort of think about handling and initializing strings. The other way is you can do it this way because we are just dealing with arrays. And this is sort of like when we were in the arrays video assigning values this way, before we started like looping over them and all that kind of stuff. You do have the option of just taking it one line at a time, handling the string characters at that specific index. So we're going to do an L, and then we'll do another L, and an O. But if we go ahead and this will work But if we print the string, we'll run into the same problem that we ran into before, where it's not properly null terminated. So this is sort of a general rule for strings. When you assign space for a string, because this should be an array of 5 characters, HELLO, you always need one more space than you think you'll need, because you need to include space for the null terminator. So even though this string is only 5 characters long, we actually need 6 characters. Sorry about that. And when we run this, we'll see that it works now. Make sure to include an extra space for your null terminator. So if you think you need 5 spaces, you actually need 6. And hopefully that makes some sort of sense. It's just a way to tell the compiler that your string terminates here, it's done. Otherwise it'll keep trying to read and it'll wind up pulling garbage values from memory. So hello is 5 characters long. We actually need space for 6 characters so that we have space for that null terminator. So I'm going to go ahead and leave this here. But I'm going to go ahead and show you maybe an easier way to go about implementing strings in C. We'll do it down here. This is another option you have for auto-initializing your strings. We can do something like this, equals hello. And we'll go ahead and print this. And what you might be expecting, because I didn't include a null terminator, is those garbage values again. Sorry, this is an array, so we do need the brackets. But you'll notice that they are not there. When you auto-initialize a string this way, with the double quotes, and then you just write out the string, so you're not doing this sort of thing where you're actually, doing it 1 character at a time. You're using this sort of double quote notation, writing the whole string in there. The compiler, or the C language really, in the back end, automatically appends a null terminator for you. It's like this is here, but you don't have to take care of it yourself, because the C language will do that for you. So when you initialize strings this way, or read in a string from scanf, or anything like that, you can not worry about the null terminator. So that's sort of a nice advantage of doing it this way. And also it's probably just more convenient. So my recommendation, even though you should know what's happening here, is to probably get in the habit of initializing your strings this way, because it just makes it easier to work with, and it's a lot more readable too than this, and it takes up less code. So that's probably a good thing to keep in mind. Let's go ahead and do, just for completeness' sake, we're going to make this an empty or a blank string for now. We'll give it space for 50 characters, which is probably more than enough. I'm going to scan something into the string. Printf, please enter, I don't know, your first name. And we'll scanf %s. Normally, you would do this. Ampersand my string. If we go ahead and run that, we get a warning. Argument 2 to scanf does not match the format string. And I'm going to go ahead and try and print it, because it's important to know that this will work, but it's not correct C. And it can lead to some problems when you start getting into more things with pointers. To make this warning go away, and this is something else to know, you don't use an ampersand when you're scanning in a string. And I'm going to write that up here. Do not use an ampersand when scanning in a string. And you'll understand why more when we talk about pointers. So if I run this program now, I'm not getting that error. It still works. You're not going to see any difference in the output, but it could cause problems later on down the line, depending on what you're trying to do. So that's how you use strings with the scanner. And I'm going to go ahead and comment this out. And what I want to talk about now are some of these string library functions that we've gone over in class, and I think would be good to know for the test and for some of your assignments. There are really 4 or 5 main ones that we've gone over, so I'll go ahead and write them out here. We're going to talk about strcopy, strcat, strlen, and strcomp, and then stricomp too. We'll sort of talk about last, although these are very closely related. So let's go ahead and talk about strcopy first. Let's go ahead and make a string, and we'll have it say hello again. And let's go ahead and make another string, but not actually assign anything to it. So it'll just be a string that has space for 50 characters. We're not assigning anything to it. Let's say we want to copy the value or the contents of this string, my string, into my string too. And this does need a format, or a data type. If you've worked in a language like Java or Python, you might be used to being able to do this. This will not work in C. If I try and run this program with all this stuff commented out, you'll see that I'm getting an error. Operands of equal have incompatible types. That will not work. If we want to copy the contents of one string into another string, we need to use the strcopy function, which is included in the string.h header. So the way this function is structured is it goes destination, source. So the source is going to be the string that you're copying from. The destination is going to be the string you're copying into. In this case, we want to copy from this string into this string. So we're going to do my string is going to be the second argument, and the first argument is going to be my string 2. This is our destination, that's our source. So now let's go ahead and printf my string 2 and see what happens there. And we'll go ahead and run this and we'll see hello. So hello was successfully copied into my string 2. So that's what strcopy does. I'll just write it out. Used to copy contents of one string into another. So str2 now, or my string 2, says hello. Let's say we want to make it say hello world. In a language like Java or Python, you would be able to do something like this. But you can't do that in C. This also will not work. If I try and run this, it gives me more errors. This is where strcat is useful. It's short for string concatenation. You know, to concatenate just sort of means to add something in like a series. So what this will let us do is it'll actually let us append things, more strings, to the end of a string. So, and I think the best way to sort of understand that is to see an example. Again, we're going to go destination source. So our destination is my string 2. This is the string that we want to modify. And our source is going to be what we want to add to the end of it. So in this case, we want to add world to the end of it. So let's go ahead and print that. We'll go ahead and run this. And we'll see that our program says hello world. Note that it doesn't include a space between world. strcat will not do that for you. So if you do want a space there, you'll need to write that yourself, which is a pretty easy fix. And there we go. Now it says hello world. So we've successfully appended a string to the end of another string. And notice for all of these functions, you can either pass in string variables or you can pass in a string like this. It doesn't matter which one you're actually passing in because these are both strings at the end of the day. So you could have a string that actually says world, you know, something like this. And you could pass that in, or you could just hard code, you know, world. Either one will work. So that is strcat, used to concatenate strings. strlen, super simple, used to get the length of a string. And it counts the number of characters in the string and returns it. So let's go ahead up here and make an integer for length. And we'll say length equals strlen, and we'll get the length of my string 2. And now we'll just go ahead and print it to see what happens. And I happen to know, because I've been programming for a while, that hello world, including the space, because you do have to count the space and the number of characters, is 11 characters long. So hopefully that's what we see when we run this. It's not, because I passed in the string and not the length. My bad. Yeah, and we'll see that it's 11 characters long, and we can count this 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So that's what it does. You take a string, it counts the number of characters in the string, and it returns it as an integer value, which you can store and use for, maybe for example, if you wanted to loop over a string, you know, for I equals 0 while I is less than length, you could do that to get the length of your string. For some reason, that's maybe where that would be useful. Or if you just wanted to know the length of a string in general, that's how you would get it. So, pretty useful function. strcomp is the next one. I'm going to make some new strings for this one. Check string 1. Let's say this one equals hello. And char check string 2. Let's say this also equals hello. strcomp, or strcmp, is used to compare strings. And what it'll do is returns 0 if two strings are the same, returns greater than or less than 0, less than or greater than 0 otherwise. If you know anything about your ASCII table and all that kind of stuff, what it really does is it checks for the ASCII values of the strings and determines which one is greater, and returns -1 or 1 depending on which string is greater. For the purposes of this class, all you're really going to be doing with it is checking if strings are equal or not, so you don't really need to worry about the rest of what that function does. So here we have two strings that are equal, so we know that if they're equal, they should be returning 0. So let's trap that in an integer. I'll just have one called comparison. And I'll say comparison equals strcomp, passing in check string 1, which is hello, and check string 2, which is also hello. And if I print this, I should hopefully see 0 if everything's working right. And I do. So now I'll go ahead and modify one of the strings, and I should see either 1 or -1, depending on which string is determined to be greater. And I see a 1. So that's working. What about cases like this, where the strings are equal except for the case? strcomp is a case-sensitive function, so it still doesn't return 0. And I'm going to write that here, and I'll write it up there too. strcomp is case-sensitive. So what that means is it will not determine that two strings are equal if they just have different cases like this, like an uppercase and a lowercase. Those are not equal to strcomp. If you want to ignore case, you can use stricmp, or depending on your C compiler, you might see other functions like strcasecmp or _stricmp. Try all three of these and figure out which one works for you, because I know on most Linux environments it'll be strcasecmp. On Windows environments it'll be either this or this. Macs can be either this or this too. So it really just sort of depends on which C compiler you're using for which function will work. So try all of these, they're all equivalent. But basically, case-insensitive version of strcmp. So it compares two strings, returns 0 if they're equal, ignoring case. So I'm going to go ahead and set comparison equal to, and in my case it's going to be _stricmp. Passing in check string 1 and check string 2, and remember these are equal except for this uppercase and lowercase h. So now when I printf comparison, for this one it shouldn't print a 0, but for this one it should, because it should determine that they're equal ignoring case, and that's what happens. It prints a -1 and then it prints a 0. To actually use this, you could do something like if comparison equals 0, printf, then the strings are equal. So you could do this to sort of check if two strings are equal. Maybe you have an example where you have a list of usernames and you want to compare the string to those usernames, you could use something like that. And if you found a match, you would know that would happen because stricmp returns 0 or strcmp returns 0. That's sort of an application for those functions. But that's basically how they work. And those are all the functions you'll really be expected to know and work with frequently. There are some other ones, but they're not as useful as these. So for that index card, these are probably the main ones you're going to want to write down and make sure you know how they work. So hopefully that gets you started and clears up some questions you might have had about strings.